We're here to talk through this killer Sudoku puzzle. It has some simple observations and also some really tricky observations, which made it have quite a variable solving time from our test solvers. One thing that's definitely helpful, and it comes up in, it looks like 5 distinct cages in this grid, is to know exactly what a 21 sum in 3 cells can look like. The 3 options for it are 9 plus 8 plus 4, 9 plus 7 plus 5, and 8 plus 7 plus 6. And a key observation at the start of the puzzle is that some of these cages don't have all 3 potential sets available to them. For instance, this group can't use a 6, it can't use a 4, so it's going to be 9 plus 7 plus 5. If a 9 has to go in the cage, it has just one spot it can go in, and if a 5 has to go in the cage, it has just one spot. So completing this group entirely at the start is something you can do if you recognize the effects of these sums. The 6, 4, if we look up in this column, has a similar effect to make these 3 cells have to be a 9 plus 7 plus 5. We don't know the exact order those digits will go, but that's how we break apart that group. We know that a 6 is going to be in this 21 group somewhere. And in this group, it's not an 8 plus 7 plus 6, so it's going to be one of these options. So we know a 9 is somewhere in this group. Not tremendously valuable yet. Up here, it's not 9 plus 7 plus 5, so we actually know, although we can't do much with it, that an 8 is somewhere in this cage. This corner is where we can do the most. Other sort of start the bottom 2 options with a 7 present or gone. So this is a 9 plus an 8 and a 4 in some order. And we'll, after placing that in the grid, we can get going to the next common sum that's used a fair bit 3 times in this puzzle, and that's an 11 in 4 cells. You may have encountered this in cockroach puzzles before. It's a pretty common breakdown, but it's actually a 4th set, which is 1, 2, 3, and 5, since this group can't have any repeated digits. So a 5 has to be somewhere in the cell. It can't be in these 2. A 5 has to be in one of these cells because it can't be in those. We can get some progress like this. The 5 is going to have to be in some of these cages. And what we can also do with that, though, is make an observation like this 7 has to be in the top in one of these cells. That gets us over here to this 7 is in one of these cells. And this is where I ran into the first of the, I would say, very hardest deductions in this puzzle. But it had to do with considering the position of the 7. And there are certainly valuable and legitimate ways that it fits in the bottom group. But this 21 in 4 cells looks a little uncommon. And so the thing you have to consider, if I put a 7 into this group, I already know I have a 6 in this group. I have 7 plus 6 plus 2 digits that add up to 8. The normal thing with an 8 sum is that it can be 1 with 7, it can be 2 with 6, it can be 3 with 5. But it actually turns out in this group, we've already used the high number 7, so we can't have 1 plus 7 in this group. We've already used the digit 6, so we can't have 2 plus 6 in this group. And the 5s that could fulfill a last sum 3 and 5 as an option can't go into this cage. So there's actually no potential way to have a 7 and 6 work together in this group. That's quite unusual for a deduction of this sort, but often in the hardest killer Sudoku puzzles it will be something quite subtle that when you consider a group and look at the options you can find. So anyway, the conclusion is the 7 is down below. The 7 now forces 9 plus 7 plus 5 as this whole group, so we can actually place these digits in the grid. I'll get this as a 5. The next kind of spot I made a single point of progress, but it wasn't too helpful, was down in the bottom. I was looking at the digits 9. A 9 isn't going to go into this cell. A 9 could come to this cell, but the adjacent number would be a 2, and that's already blocked in the group. So say a 9 is down here. these will come up to the top and force a 9 in this spot. That puts a 9 over here. Yes, this actually gives more progress than I remember. We get a 9 in this corner. That actually finishes out this whole group. 9, 5, 7 like that. The 5 over here comes to the top. We have a 7 in some number of those cells. Something that we now actually get is a 9 is in one of these, and a 9 is in one of these. We can now conclude that this 21 is 8 plus 7 plus 6. We can say that because the two options include 9s. Can't get into that cage. So the 6 has to be here. We need to get a 7 into this group. And you'll see that we already have concluded that the 7 in the 4th row is in one of these two cells. So we can actually say it's exactly that spot. That puts the 8s over there. You get an 8 coming down here. Seeing if there's other progress. So we get a case where one of these two cells is a 7, but we already went to great lengths to say a 7 can't go into this group. So the 7 is here. And coming to the top, we get a push like 7, and the remaining sum is 4. The 4 is in one of those cells. And here there's maybe a little more progress you can do. One kind of thing you can say is that this 21 cage is going to be 9 plus 6 plus 2 and 4. It has to be two numbers that add up to 6 total, and 1 and 5 aren't an option because the 5s are away from that group. So you could say that this cell is a 2, 4. What's actually a little less obvious immediately, but you can see from this, is actually one of these two cells is a 2. Looking across, there needs to be a 2 in this group to get to that sum of 11. So we actually get that elimination. You get a 2 up here. And this is where I found the next less common deduction, but one that was really helpful for me to get through the puzzle. And that was to consider this cell and that cell and see those have to be the same digit. Notice the bottom is 4, 8 blocked from this group. Whatever digit comes in here is a 1, 2, or 3. It's not yet in this region, but it can appear twice in this whole cage. So if this is a 1, this cell here is a 1. If this is a 2, that cell there is a 2. If this is a 3, that cell there is a 3. What this means is that of the remaining digits up here, this whole group over here is 1, 2, 3, 1, 2, 3, 1, 2, 3. We don't know exactly what yet, but this cell in the second row and third column is a 6. That gives us these being a 6, which gives these being a 6. We already had one of those coming across. We can actually place these two numbers. That places this 9, forces the 8 down below. Again, this is where my standard notation style in these puzzles gets you a lot of quick progress. This cell here is a 2, 4. We have a 2 is in one of these two cells. It can't be here, it can't be in those. That means that in this 11 box, the 2 has to be in a spot that can get the only option left, I think, is exactly there. Yet this being a 2, this is a 4, this is a 2, we have a 1, 3 left over. We got a 4 for that space. This top spot here is a 4. Over here we have a 4 to be determined. And there's still a lot of work to do, but we're making headway. And see what might be the next valuable thing to look at. Thinking about 6s in the space, particularly this whole column. A 6 can't be here. A 6 isn't going to be in this 11 group. A 6 is already filled there, and 6 isn't there. I think this is the unique 6 in that column. gives this as a unique 6 there. We actually had a more trivial deduction I could have done sooner, which is this is an 8. The big number has to avoid this group that only has small in its sums. When that comes up here, we get something like this. This is 1, 3, 1, 3. And we're going to again be in a situation like we were up in this spot, where you can conclude that whatever digit is in this cell is also in that cell. It's going to be a 1 or a 3, but what it means is the 5 is moved down below. Puts the 5 over here. We've now filled in enough of the numbers in this bottom row that we can uniquely identify the sum. Notice that it can't be 2 and 9, it can't be 3 and 8, the 3 is already used, it can't be 5 and 6, this has to be 7 plus 4. There's only one option for that. It forces a lot of digits. In this bottom space, this has to be an 8. The last digit in that row is a 6. 2 and 3 are left over here. So we get a 1. This 2 forces over here a 2. The 4, 8, 4, 8 we can mark because we've had that for a while. Get this 4. The last digit that can be in this space is a 1. We already know it's going to be the same digit as right here. This now finally clears up the 1, 3 pairs we've had on this side. So I'm just going to write this fast, but the logic is just following through with things we know. Similarly, in this space, there is a 1 and a 3. We can fill those out, finish these columns. The cell that remains is the last place for a 3. We put that digit in, so we should actually add it here. This is the last place for a 3 there. This is a 1. That's a 1. This top last cell is an 8. 8 versus 6. The 6 over here has just one option left. This row has just one number left. Put the rest of this. This is 2, 4, and 8. 8 is there for 2, 4, and the last 2. And so that took a little while to get going, but then came together rather fast at the end. The hardest things that I found were definitely this 21 sum in 4 cells that excluded the 4. And then it was nice that in this impact of geometry you could eventually find these pinned cells, and those were quite helpful to get through. So not always the most standard deductions that you'll see in these kinds of puzzles, but definitely things that were worth highlighting, since they're maybe extra tools will be helpful as you solve more and more of them. Thanks for listening. We'll see you again.